Уважаемые коллеги, я рад.
Distinguished colleagues, I'm happy to launch our next session. This session will open with a postponed presentation. We open it with a report by Engelbert Breg. Engelbert Breg represents company Vexcel, and he will speak about the power of multi-ray photogrammetry.
So, I need to put this a little bit further.
Proposing just to take it, it will be
Excellent.
it will be more convenient.
Okay. So,
20 minutes.
20 minutes? Okay, I will talk quite fast. Good afternoon, ladies and gentlemen. Finally, I made it to come here because my flight was delayed and I arrived at 3 o'clock, so I was a little bit in a hurry to make it in time. But finally, I made it, and it is a pleasure for me talking about the power of multi-ray photogrammetry. And how is multi-ray photogrammetry related with Vexcel imaging and Microsoft? In the year 2005, Microsoft introduced their Virtual Earth program. And the vision of Bill Gates at this time was that he wanted to have a virtual Earth where you can walk in the street, you can go into a house, you can touch a book, you take the book out, you read in it, and if you like it, you are going to buy it. And for this virtual Earth, he needed images. And his vision was to have 3,000 cities within 5 years online. And of course, when you have such a huge project like the Virtual Earth project, you need somehow the technology which is able to handle that huge amount of images, those processing and the terabyte and petabyte of pixel. And at this time, there was one company, a small company in Austria called Vexcel Imaging, who already dealt with multi-ray photogrammetry. And this should be the result of the Virtual Earth, a 3D world. But finally, Microsoft found out 3D is not the way. Somebody would like to see the world, but you would like to see the world in reality. So they swapped over in the year 2009 to Bing Maps. And with Bing Maps, there was a little bit a different approach. The approach is not to use 3D models, but to use street-side photogrammetry, to use aerial imagery, satellite imageries. But due to the leak of a full coverage of images, that actually was the situation. Situation was that you had inconsistent quality of the images, you have fuzzy color images, in parts of the world you have only black and white images available, or the resolution was 1 meter or even lower. And not only Microsoft suffered from this one, but with Google it is the same thing. And due to this, Microsoft started again to move into a new era and introduced the Global Auto Project. And the Global Auto Project has in mind to capture in the first step USA and Western Europe in a 30 centimeter ground sample distance. And that means 10,400,000 square kilometer of captured images. That means 238 terapixel. And that means 1.2 petabyte of raw imagery. And you can imagine what that means for somebody. What are the challenges when you do such a huge project? The challenges are that the projects which needs to be flown are getting bigger and bigger. Before we talked about 1 meter resolution, now we talk about 30 centimeter resolution for the whole world. And the amount of data goes up tremendous. When we talk about megabyte, then we talk about terabyte, now we talk about petabyte. Beside this one, where we have no influence, is the weather. The final finish of the Global Auto project should be in 2012. That means within 2 years you should cover USA and you should cover Western Europe. But you have no influence on the weather. How can you manage that? That means you need a huge fleet or fast capturing instruments. And beside this one, when you have captured the images, how do you process it? All the amount of data, and we heard about 2 years starting with capturing the imageries and have everything online. So these are the challenges of this huge project. And let's start with the points. The projects are getting bigger and bigger, and the data are getting more and more. And this brings me into the camera system. When we look at the evolution of the cameras, in the year 2003, Vexcel started with the Ultracam D. And that was at this time a large format camera, 11,500 pixel by 7,500 pixel. Nowadays, we call this size a medium format camera. And the large format cameras has about 20,000 by 13,000 pixel. But this is a must if you imagine that you would like to cover 2 continents within 2 years. The next challenge happened due to the fact that we have the 11th of September, which changed the world also. Before 11th of September, the restriction in terms of flying was not that big. Nowadays, you have restrictions. London, Paris, you are not allowed to fly below 4,000 meters, but you would like to have the 30 centimeter ground resolution. So that means you need somehow a flexible system which is able to swap the focal lengths. So in this case, we have developed a camera which can exchange the lenses in the field without recalibrating. Nowadays, the digital camera can do the same thing as the analog camera could do 10 years ago. So we see data capture goes into one direction, but still we have no influence on the weather. So what can we do? We have several options. We have the options that we say we stop the current mission, or we refly the project area when there's a nice weather, or we live with not perfectly imageries, or we work with different light conditions. If we work with different light conditions, then we need somehow a process, an algorithm who is able to get rid of all those hotspots, of all the haze, and should do radial correction of the full project. And this radiometric correction should not be done on a single image, but this radiometric correction should be done on a complete project. And that brings me to another change in technology. Think back when we did radiometric correction single image by single image. This is the past. The future is project-based color balancing. Project-based color balancing means that I use GPS data where I have the date, the time, the location. I know exactly where the sun is, so I can get rid of the hotspots, and I can get rid of the different flying times. So in this case, I pull images together, and in front, I hope you can see, yes, it looks good. So what you see is the output of 2 flying days, different radiometry. And with one click, you make it homogeneous. And you do not care about one single image, but what you do is you care about a complete project. And this automation is necessary to run projects like the Global Auto. And then the processing time. 256 megabytes are by far enough for a computer. That is what the CEO of IBM said in the year, was it 1974, I think, or was it earlier? I'm not sure about the time. And nowadays, we have farms which uses massive of CPU power. And in this case, what we do is we have a complete workflow where you run from the aerial triangulation into a dense matcher. From the dense matcher, you produce the DDM and the point cloud. Based on the DDM and DSM, you produce the orthophoto. And finally, with one software, you achieve orthophotos, point clouds, DSM, and DDM. And this technology is based on multiray photogrammetry. Multiray photogrammetry means to fly in a very high overlap, 80% forward, 60% sideward overlap. In certain cases, for example in New York, where we had the very, very high skyscrapers and the very small streets, we flew even 90% forward and 90% sideward overlap. And the result is that you have one building, as an example in the presentation, and on the building you see all four faces. This is one advantage of the multiray photogrammetry. And the other advantage is that with a source of high-resolution images with a high overlap, you achieve up to 12 rays per point. And based on this one, you can produce a very, very dense point cloud and a digital surface model. And the point cloud, which is produced out of aerial imageries, is extreme robust due to a high redundancy. And the dense, you have 50 and more points per square meter. And the accuracy is depending on the GSD, but in this case, for example, when you have a 10 centimeter, it is smaller than 10 centimeter. So we're talking about an accuracy X and Y in half of a pixel and Z direction 0.7 of a pixel. And this in a fully automatic workflow. And the output is, as an example, hope it works. Unfortunately, the video doesn't work. So this is an example. Doesn't. Okay, so we can use this one. So this is now the output of multiray photogrammetry. This is the Frauenkirche in Dresden. A high dense point cloud produced from aerial imageries. And in certain places, in certain things, it will replace LiDAR as well. Because in this case, when you do a 3D model from buildings, you do not need the LiDAR anymore. So now I need to stop this one. And then the next step, which is a little bit of magic, I say, the algorithm in the background. From the DSM, you produce the DDM. The only thing which is questionable is, does a bridge belong to a DDM or not? That is something which has to be defined. So we have it now in here, but in total you could also remove the bridges out for the DDM. Multiray photogrammetry means a lot of sources, a lot of imageries. And with these imageries, you have a high redundancy. For example, 12 rays. And with this one, you are able to achieve a single DSM orthophoto. And now people ask what is DSM orthophoto, and I ask back what is true orthophoto. DSM orthophoto is related on the DSM. With true orthophoto, I have absolutely no idea why it says true. Yes, it is the same, it is just the wording. So I know the DSM is the base with a true orthophoto. Is the true behind it? That is the question. Philosophy.
It is not exactly the same.
And this is now a true orthophoto from Graz, which is flown with the Ultracam D in the year 2004 with 50 centimeter. And you see here the building which we had before. And that is a newer one, which is a GSD of 10 centimeter, where you see the DSM of Graz. And based on the DSM, we produce the true orthophoto or the DSM orthophoto. And this technology has been proved since the year 2006, because since 2006, the algorithm which is inside of this software is also used in the Bing Maps project. And finally, the conclusion of this one is a global auto project which has been captured 100% of the USA just recently. 98% of Western Europe is also finished, so we just wait for the last 2%. And then 2013, 2014, we start again, recapture the images, and it is only possible because there is a highly automated workflow in the background which is able to handle that huge amount of images, which is able to handle the challenge which we had. Thank you very much.
Большое спасибо. Вопросы?
Thank you very much. Will there be questions for the speaker? I have a question.
Yes?
You mentioned about Winston-Salem filtering from DSM to DTM.
Yeah.
Is it development from your company or it is third-party development?
It is a certain part of development by our company, and the certain part is taken over by the algorithm. Yeah.
Okay, thank you.
Yeah, you're welcome.
Еще вопросы?
More questions? Tell me, please. Is there such a city as like 1,000 kilometers? How much time would you need to post-process this 1,000 square kilometer city? A town with high, tall buildings for the scale 1 to 1,000 with a 10 centimeter resolution. And you want to acquire orthophoto for that? Yes. На самом деле, очень хороший вопрос, на него просто не ответишь. Я могу лишь ответить.
Flown Graz in an overlap of 80%, 60%, which is roughly 20 by 20 kilometer. In ground sample distance was at this time 8 centimeter. So the complete project, capturing the images and the final DSM orthophoto took us 1 week.
Including DSM?
Including DSM, including the cloud.
А сколько времени заняла сама аэрофотосъемка?
And how much time did take to capture all the images?
Taken in 1 day. The advantage in the aerial survey is when you have a high frame rate.
Last question is the price.
Yeah.
Последняя.
Just the short answer on his question. The reason why we can capture such a huge area in a short time is also the time frame of the camera. You can fly fast, and when you have a frame rate of 2 seconds, or in the past with the Ultracam D we had 1.3 seconds, so that means you can fly at the highest speed with the aircraft. And that gives you the advantage that you can capture a certain area in a shorter period or a larger area in the same time.
Well, I also have one question. So all this DSM order, well, true order, whatever you have mentioned. So everything is done automatically. Everything was done automatically, completely.
Yeah.
Okay. No question.
Could you mention something about the capabilities and the status of the Ultramap 3 software? And how does it compare, for example, to such programs such as the Austria Vexcel factory?
Ultramap version 3.0, which includes this algorithm, is currently available as a customer preview version and is available for the Ultracam. So in this case, with 60% forward or 80% forward, 60% sideward overlap, you're able to capture images like I have shown here. When we talk about automation, I would never say that it is a fully automatic workflow in the real production. It is a highly automated workflow. Highly automated workflow in this reason, because from customer to customer, it depends how people see the quality. In some cases, you can run a fully automatic project, but then you have not the sharp edges. If the customer accepts it, fine. Otherwise, it needs a little bit of manual work. Coming back to your question, the Ultramap version 3.0 will be available by 2012, so November, December this year. And then the workflow, which you have seen here, is available for commercial companies.
Does this program support only Ultracam imagery?
It supports only the Ultracam.
Only Ultracam.
Yes. So if somebody wants to have another camera, then I would say take Rakus.
Mm-hmm. Okay.
You didn't. Can I ask one more? You didn't talk about georeferencing, triangulation.
Yeah.
I assume it's also fully automated with no problems, or do you have to interfere manually? Do you need GPS on board and IMU, or can you do it fully automatically with no interference, without GPS and without IMU? Triangulation.
I split your question into two parts.
Yes, please.
I split it for the Bing Maps project, and I split it to the commercial market. In case of the Bing Maps project and in the commercial market, there's one identical system. So we use GPS IMU, and we use also ground control points. So means for a commercial company, there is some manual work to do. Measuring the ground control points, put the ground control points inside.
How about tie points? Tie points.
Normally,
measurement of tie points.
If you have 5 tie points, 4 in the corner, 1 in the center, and you have a nice 80% forward, 60% sideward overlap, it works. The question is always, what do you like? The higher the accuracy, the more tie points. And in terms of Bing Maps, when we talk about the second part of the question, this is a fully automatic workflow. So fully automatic workflow means the ground control points will be loaded, but there is no manual editing and no manual work.
Control images.
Pardon?
Control points are then control images.
Yeah, yeah.
One more question. Engelbert, one more question. How do you fly oblique imagery? How do you do oblique imagery actually? Actually, you don't have oblique
No.
camera. Ultracam it is not oblique.
We do not have oblique cameras. Although, as you have seen in the presentation, there's one point. You fly in a very, very high overlap. You fly in an 80% forward and 60% sideward overlap. So that gives you, in a certain way, the face of the image. And this face of the image can be put on the DSM, and then you have certainly something like an oblique.
But the maximum field of view that you have, it's just 75, 72 degrees.
Yeah?
It is not oblique image.
No,
actually.
it's not oblique.
This project for Bing Map or for Google,
The
for
Bing
example,
Maps
uses
the oblique camera of
pictometry.
pictometry.
You are flying with pictometry.
Yes.
I understand.
Yeah. He will translate.
А он исказит мой вопрос.
А? Традиционный вопрос?
I think he will distort the meaning of my question. Anyway, today we heard about the new developments of A3, DMC, and ADS. How would you comment on the advantages of Ultracam compared to the above-mentioned cameras?
A3 camera,
Yeah.
DMC, and ADS 80.
Yeah.
How do you, how would you comment advantages of Ultracam camera against all these cameras?
It is always a nice question when somebody asks, how do you compare the competition with your camera? Well, I answer your question in a very simple way. Vexcel imaging came onto the market in the year 2003 with a completely new technology, syntopic exposure. One image built out of 9 images, stitch them together, and you have a large image. We were a newcomer against Leica, against Intergraph. In the year 2006, Vexcel overtook Intergraph as well as Leica and became the #1 on the market. In total, we have now roughly 400, 450 digital aerial cameras on the market, talking about large format cameras, I have to say. 250, even more, 267 are Ultracams. And that convinces me that the market made a decision that the radiometry, that the geometry, and that the principle of the Ultracam is the leading technology on the market. And, well, yeah. So more or less, people has given the answer. It's not me who has given the answer.
Но это было вчера и сегодня.
But it was yesterday and today. What about Vision Map, who are not standing still, they're moving forward, they're developing? What about Vexcel prospects about that? Но сейчас отвечу как представитель отдела продаж. Когда я увидел впервые камеру Vision Map, я подумал, о, очень интересная, умная технология. И потом я вспоминаю вот то время, когда Vexcel также был такой умной технологией, когда мы впервые вышли на рынок. Я бы сказал, что Vision Map — это очень интересный, удобный инструмент, имеет свои преимущества и недостатки, конечно, как и все наши камеры, несомненно. Поэтому, если будете охватывать большую территорию, сейчас я беседую с вами, если охватывать большую территорию пролетом, и вы будете делать очень качественные снимки, очень быстро, я бы сказал, что в этом случае у Vision Map есть преимущество. Если же вы хотите делать реальную фотограмметрию с очень низким GSD и качественные снимки, тогда Vexcel Imaging будет лучшим выбором. Вот как я отвечу на ваш вопрос. Хорошо, большое спасибо.